So first of all, LCA is not one or the only tool that is available to assess the environmental aspects, but it's the most commonly and widely used tool to calculate the environmental impacts, and is very effective on the micro and meso scale. So on a very detailed scale, it's very effective. Also on a meso scale, and when I mean this, is like the product or the system that is involved in a considerably medium to small scale. But when we are talking about very big scale, like the scale of countries or many products or economic sectors, it doesn't make sense to use LCA. So for that, there is other tools. And also on the economic aspects, LCA is definitely not the tool to be used. So it's very much focused on the environmental aspects. And so just to give you an idea that there are many tools out there, but LCA has a very specific application, which is mostly effective on micro scale and of course focused on environmental aspects. And for the case of the project, of STAR project, that is exactly what makes sense to use is the LCA tool. So I would just highlight that LCA has in this slide mostly two perspectives. So it's cradle to grave or cradle to gate. So it's a more like a whole life cycle perspective from the extraction of raw materials until the end of life, or a more smaller perspective from the extraction of raw materials to the manufacturing and basically to the use stage. So it depends, these two perspectives, it depends on what we want to do with the LCA. And of course, in LCA, because this is a very data intensive methodology, we should always be very careful when we do the methodology, because this can take we should not take an additional effort if we don't need to do that additional effort, or if that does not benefit the objectives of the methodology. So just a few definitions which I think are fundamental. So first of all, to be very clear on what is life cycle and what is life cycle assessment. So two different things, of course. So life cycle is basically a consecutive and interlinked stages of a product system. So from the raw material acquisition or generation from natural resources to the final disposal. So the diagram below basically systematizes what are the set of stages that compose a life cycle, a complete life cycle, from the extraction of raw materials, production, distribution, then you have use, and then you have the end of life, which can be reuse or recycling or maybe incineration or landfill. So this is what is life cycle and life cycle stages. When we are talking about life cycle assessment, what we are talking about is doing on top of these life cycle stages, we are compiling and assessing or evaluating the inputs, outputs, and the potential environmental impacts that happen in each of these stages and the whole set of stages that compose the life cycle, the complete life cycle. So two different things. There are also a lot of standards nowadays to establish how we should develop the LCA. LCA cannot be certified, so it's a methodology which is developed, and if a product is or if we do an LCA on a product or a system service, we cannot certify that LCA, but it's also a methodology that benefits a lot from having a third party or someone independent that is accompanying its development, and although it cannot be certified, it can be reviewed. But so I'll leave this slide for later if you want to check some of these norms, but it's not really critical right now. So LCA is also, when we develop an LCA, it's this kind of structure. So it's a process-based model where we have subsequences of processes interconnected with themselves, and they exchange matter, or they exchange energy. So that is how we build the LCA model. And processes can include other processes. So it's a set of structured process-based model. Some of its terminology, which is important to take in consideration, is that, of course, we have economic systems which have processes in which those processes can exchange flows. And those flows can be matter, can be energy, can be heat. What we are measuring with when doing a life cycle assessment is the exchanges between the product system and the environmental system. So there is a boundary which exists between those two systems, conceptual boundary, of course, and for those we account the exchanges between that go across that boundary. So the inputs, mass, radiation, heat, energy, and also the output. So what goes out from the product system to the environmental system. Most important, we have to connect or interrelate those exchanges between the product system and the environmental system via a functional unit. So we have to establish the relation between those exchanges and a functional unit. And I'll talk a little bit later on what is a functional unit. So what I have been showing so far was mostly the life cycle stages. So the product life cycle or the product system. Now this diagram is the LCA part. So it's the sequence of stages that comprise the methodology for life cycle assessment. So just to separate from the previous slide. So previous slides, we were showing life cycle stages. Now it's the methodology, the work methodology. So these are a diagram for the operations that we are doing during the methodology. So we have basically, when doing an LCA, two parts, the life cycle inventory and the life cycle impact assessment. Usually the life cycle inventory is the stage that takes a longer time to do. It involves, first of all, the definition of the goal, the objectives of the assessment, and also the scope. So what is the product system that we want to model? How big, how small? What processes, what operations do we want to include? What operations do we need to include? And what are those that we don't need to include and they should be kept out so that we don't lose energy and time accounting for those. So the first part, life cycle inventory, includes the goal and scope definition, and the second stage, which is the inventory analysis. So inventory analysis accounts for the accounting of all of the inputs and outputs that comprise the life cycle stages. So this is usually the most time-consuming stage, and this is something that we will be needing your support because we will be needing your data. Of course, we use a lot of literature data and also databases that we have in our company. But it's one of the objectives of this task is to do the LCA as close as possible using real data from the field and from the processes and operations that we are using for these for our project. Then the second part is basically builds on the first part, which has the flows and of matter, energy, and all of that, basically to assess the life cycle impact. So there is methodologies which I will explain in just a few minutes that do the relation between the physical flows and then the impact flows, how that affects the environment, and then how also the changes in the environment can affect damage. So basically to human health, or to resources, or to the ecosystems. So these are the steps to do the LCA methodology. And as I told you, we need to do that related to a functional unit. So the functional unit is probably the most important concept in the LCA methodology. So whenever we will be doing an LCA, we'll be accounting for inputs and outputs, so energy, mass, all of that. But that has to be related to a unit of a given function that the product that we are doing provides. And that is the way that we can then measure and have an indicator about that product and how it should compare with other products or with different products, but with similar functions. So that is why we need always to have a functional unit for every LCA that we do. And that, for the case of the START project, is something that we have been discussing in the work package, but we will have to then establish a definitive functional unit that can be the one that we use for the START project. So this is mostly what I've been describing here, the LCA stages. I would like also to talk to you about the principles of doing LCA. So it's very important to have these in consideration while doing the methodology. So first of all, of course, the life cycle perspective. So we have to look at the life cycle in a systematic way, looking at the different stages and trying to include as much as possible all the stages of the life cycle that are relevant for the objectives of the LCA in particular. So of course we will have to address the environmental aspects and impacts of the product system. So that is our focus. We also always have to do an approach which is relative to the functional unit. So it's very important to do that initial step of defining the functional unit. Also, the way that we build the LCA, because it's so extensive and so intensive in data, is that it's very common to do it iteratively. So we go back and forth to the different stages, and we are always reviewing and updating with new data that may come into play, and also updating the results and updating necessarily the interpretation of those results. Also, it should be transparent. It's because it's not a certified or a certifiable methodology. It's very important that we can demonstrate how we get to the results, and the way to do it is basically that we have all the data that we are using well, made available. I would not say made available to the public, of course, because we will be probably using some data that is very well, confidential in some cases. But the result should not be falling from the sky in a way that we cannot demonstrate how we got to that result. And I think that is very important to give confidence to those people that are listening to our results, and they have to believe in those. Also, comprehensiveness. So we should consider all attributes of the environmental impacts in the life cycle assessment. So not just look at the indicators or the environmental aspects that we benefit from and forget about those that are negative, or vice versa. So there should be a comprehensive readout of the results. Also, of course, LCA is a scientific-based approach, and it should always be, whenever possible, based on natural science. It sometimes happens that it's not possible for every stage, and in those cases, it's possible to use, of course, social and economic sciences, and some conventions that are used to overcome some of the limitations of LCA, or some of the limitations maybe on data, or even on the consequences of data. Just to give you an example, of course, everyone talks about maybe radiation from the 5G antennas or cell phones. How does that affect human health? Does it have any effects? There are many studies done on that, but there are no definitive, there are many conclusions, but we cannot say that in 100 years we will not find out that maybe there is some sort of impact coming from that, or this is just a random example. But just to tell you that Of course, we don't have all the information and all of the knowledge in every stage, but we have to deal with those with the data or the phenomena that we encounter in the product life cycle, and we have to account for that. When can LCA be useful? And that this is very important. It goes back to the initial slide that I showed about the different tools. And the LCA, of course, it's not the holy grail for the environmental assessment, because it cannot do all the answers, unlike ChatGPT. But just LCA is more effective for uses such as, well, from an internal perspective, to compare the environmental impacts of different products that have the same function. And this is important, that they have the same function, because I can easily compare a bicycle with a car. They are totally different products, but they provide the same function of transportation from point A to point B. But I cannot compare a bicycle with a bottle of water, because of course, they provide different services completely. So they are not really competitors for the same function. And in that case, it doesn't make sense that I should say that a bottle of water has a lot less environmental impacts than a bicycle or something like that. Also, they are commonly used to compare with a reference to a standard. So if there is a benchmark in a given sector, a given product, or a given service, we can use LCA to assess our product against that standard. Also, it's a very useful methodology to know what are the most significant environmental impacts, or where are those environmental impacts mostly coming from. So are we doing a product that has the biggest environmental load coming from manufacturing, or is it from the use stage, or is it from the end of life, or is it from every stage? So it's very useful for that, so that you can, of course, then focus on trying to improve a specific stage of the product life cycle. Also, it offers an opportunity for eco-design. So looking back onto the iterative development of the LCA and that characteristic, it's very helpful to help product designers or product engineers to do eco-design. So to test out and simulate what are the consequences of a given product design decision, and then before it goes into production, try to improve if that decision is not the best decision in terms of environmental efficiency. And also, of course, to help the companies develop or define their internal strategies, but that is more strategic usefulness, which is not so common. From an external point of view, and I think that these two, both internally and externally, they matter for us in terms of start, but the results that come out from the LCAs, they are widely used in marketing to convey to the consumers or to the authorities what are the benefits or the down parts of our life cycle. Also for information and education purposes, and of course lobbying, and also for labeling purposes. So it's very common that companies use LCA to develop then labels to communicate to consumers or to the industry in general. So LCA has a lot of applications, but it also has some applications where it doesn't make sense at all and should not be used. And as I said, so to compare environmental impacts of products that have distinct functionalities, that doesn't make any sense. So we should not use it in that case. And also, they are not, so LCA is very specific to the characteristics of the life cycle impact of the life cycle of a given product or system. So when we are talking about a product, we have to have in consideration that LCA is not only the product, but it's also its context, where the product is used, where it is manufactured, when. So all of that matters and makes a big difference. And so we should not use it to assess products or systems which are location dependent. So if we are talking about assessing, I would say, for instance, an airport, as an example, it doesn't make sense that we do an LCA on an airport, because it's totally different to have an airport if it's located in one part of the country or in another part of the country. That makes a big difference, and that's effectively what it makes sense to compare the different locations and not the airport itself. So and of course also it doesn't replace any other methodologies like environmental impact assessment or risk analysis or strategic assessment. So it's a very small scale or medium scale and environmentally focused tool. We should not use it to a sector-wide or a very big scale, because it doesn't work well in those cases. So I'll leave you with some of the LCA resources, so some links that you want to, if you would like to consult later on. We can share these slides, of course. And then, so I would make here just a brief breather, I would say. So what we have been discussing so far is mostly the fundamentals of LCA, the theory of what its principles are and how it should be developed and carried out in terms of its fundamental theoretical part. So now I will go on to a more practical side, well, not practical, but more applied side of the LCA methodology itself. So we'll go through each one of the stages that comprise the methodology, and we will discuss a little bit its specificities and how that affects. So in effect, we will be telling you over the next maybe 20 minutes what our work here at Three Drivers has, what we have to do to develop the LCA. So this is an overview of the different individual stages that, or more detailed stages that comprise the LCA methodology. So we have to do all of that. So define the goal and the scope, do the planning of the data collection. As I told you, it's a very important and very heavy load task. So it's something that we will be doing over the next steps, and we'll talk about that in the end, and all of these processes. But I will just go over these over the next slides in a more expedite way, but we'll share the slides with you, and you can of course look at them if you want to see all the details. So first of all, goal and scope. I don't think I have to go much more in detail about this, because the name is very self-explanatory. But most important is that we focus our LCA goal in what it's intended to do. So if we are doing the comparison of the product, then we should focus our goal in that. So we have to try to avoid to try and help the LCA do everything about the product or the environmental impact assessment. So it will be as better to have an LCA that has a very specific and very pinpointed goal, because it will make it easier in terms of developing the whole methodology within the time frame. And also it will make it more effective because we will have a result and the conclusions that are very specific for that goal. Of course, it's not always possible to have a very specific goal. And as I told you, this works also in an iterative way. And it's very common that we start with a specific goal and a specific scope. And then throughout the development of the methodology itself, we find that it would be interesting to extend a little bit the goal or extend the scope, or maybe include some other processes and all of that. And that is perfectly fine. So it's the way that LCA goes about. So it's no problem at all. So I will not go into this very much, but in terms of goal, we should, well, there are some types of goals, and we have to see this is for decision support, yes or no, and what level we are trying to do the LCA for. So is this for a very small micro level decision? So are we doing material A or material B, or are we doing a specific change to a given component, or is just more like a macro level about the product or the product system that we want to assess, or possibly not even to do any decision supporting, just to have like a result to account what is the impact of the system or overall, so without trying to intervene within the system itself. So it's just a diagnostics rather than trying to use that diagnostics to do any changes. So for the scope definition, this slide has a lot of text, so I will not bother you with all of this. So I'll just say that the most important part for the scope definition is that we can include all of the operations and processes that are necessary or relevant to the impacts, to the results that we will be trying to measure. But at the same time, we have to balance this with the amount of work and the availability of data that we will be required whenever we include a given process or a given operation. So it has to be a balance. And as I said, that is why this work is typically very iterative, and we are always going back and forward trying to see if it makes sense to include or to exclude a given process. So we have to begin with some sort of scope as well defined as possible, but that can be changed over the course of the definition of the LCA. And most importantly, of course, we have to document everything, make good records so that we can go back. So whenever we go back, we know what we did, and we can refer to those records to why we did that decision. So the second stage, so first stage, goal and scope definition. Second stage, inventory analysis. So the inventory analysis is the most time-consuming stage. So it involves basically accounting for all of the inputs and outputs of the processes. We have to design the process tree or the flow chart for all of the processes and then interconnections between them. We have to collect all of the relevant data, of course, and we should do the material and energy balances, so to be sure that everything closes, so that there is no input coming and then there is no output or that there is an output going out, and it should not happen because there is no corresponding input. So that everything checks out in terms of the science. So this is just one example. So we should be able then to get to, for instance, a given process to this sort of data for a given unit to account for the substances that are used as resources, and then for the outgoing emissions, for instance, to the atmosphere of the substances and the amounts, and also to the water, radiation, and other emissions. So data collection and the data calculation is very important aspects. So we have to include energy, raw materials, ancillary inputs, other physical inputs. Also, if there is some products or co-products or waste that is generated, all the emissions to air, water, soil, any other environmental aspects that can be made relevant. Also, we have to validate the raw data. So we should be able to, for transparency reasons and robustness reasons, be able to demonstrate all of the data, where it's coming from and where it was collected from. And all of that data has to be related, of course, always to the unit process and to the functional unit. So this is, as I told you, a very intensive step of the process. So also one important aspect and challenge when doing the LCA is allocation. So this is probably one of the most controversial steps when we are doing LCA. I will not bother you with all of details, but just to give you an example, I'll go here a couple slides ahead, and basically to tell you when the example of the end of life stage. So when we are doing, for instance, the end of life of a given product, let's say that we have a bottle of water, and then that bottle of water goes to the collection and recycling system. So let's say that the bottle is made of plastic and that it could be recycled. The question is, the materials are going to be recycled and they will be used to produce another water bottle, let's say. The question here of allocation is, should we give that credit of the recycling to the bottle that was the donor of the waste and the materials, or should we give that environmental credit to the bottle that was the recipient of the recycled materials? Where is the border to say who should benefit from the environmental credit? So this is an issue that, and other issues of allocation, they are widely discussed in the scientific community for LCA. But of course, there are some answers and there are some solutions already. So, but just to give you an example of how we can influence the results of an LCA if we give the credit to a product that is using recycled material, or to the product that is providing the material that is going to be recycled. So this is why it is very important that, because this methodology is not certifiable, that we have transparency in all of these decisions, so that we can effectively compare ourselves with the correct level playing field in these allocation aspects as well. So I'll move on through the allocation, also because of time-wise. So impact assessment. So this is, well, I would say, before the interpretation and the conclusions, is the most, well, one of the most important parts, where basically the inventory or the inputs and outputs are converted into impacts. And that is done using, first of all, the classification, so identification of the environmental interventions that contribute to a given impact category. So methodologies for impact assessment, they are usually built on different impact categories. So they don't mix the impacts on, for instance, soil with the impacts on air, or impacts on the water. So they have specific individual impact categories that are not related with each other. And so that is one aspect, that not the lack of relation between those categories, because of the complexity, of course, of the natural systems. It's very difficult to connect an output that we are having from the exhaust pipe of our car to the atmosphere. How do we connect that to an impact on the soil for the acidification or something like that? So typically the methods used for environmental impact assessment, they separate in different categories. Then we have a way where we can establish a relation between those different categories. And the way that the methodologies have solved that is by normalization. So they have a result for each category, and they can divide the result in each category by an average or a reference value that happens in that category. And then you can have basically results that are in percentage without any dimensions. And then you can see and compare the different environmental impact categories. Still, they are not related in terms of quantitative, and for that we have to do something that is called weighting, so pondering the different categories. And for that, the science for that is basically subjective. So it's not something that is physical or chemical science, but it's basically weighting. So it's based on questionnaires on people. How do you value more the impacts on a given category or the other? And that's how we ponder the different categories. So some of the steps for life cycle assessment are mandatory, others are optional, as this weighting part is not mandatory to do LCA, but I'll skip this. So I will just go, because of time-wise, just to show you here this slide. So this shows a better picture of what I'm talking about when doing different choices for the impact assessment stage. So there are basically, we have the inventory, which has the physical units, so the inputs and outputs for the processes. And then there is methodologies or that are called midpoint methodologies or indicators, and they classify those inputs and outputs into impacts in given categories, and those are called midpoint because they are problem oriented. So if we are emitting CO2 from a pipe or from a chimney, that can go into other, for instance, climate change, and account for the amount of CO2 that is being emitted. So that is what the midpoint indicator does. Then we have endpoint indicators, which go a bit beyond, and they look at what is the damage that CO2 emissions are going to generate, and then that is when the endpoint indicators come in. So very briefly, so we have, for instance, CO2, CH4, N2O, CFC, other gases that have greenhouse effect, and so we have emissions of that, and every emission can be accounted, and they would contribute to the problem-oriented category of climate change. So they can be converted into CO2 equivalents, and you can have a unit for that impact category, which is the kilograms or grams of CO2 equivalents. But that just tells us what is the problem, so the origin of everything, so the increase in emissions for CO2, but it doesn't tell us what is the damage that it generates. So for that, well, science assesses what are the changes in the Earth's radiative forcing because of the increase of CO2 equivalent concentration gases, and then it measures the changes in atmospheric temperature, and then it can measure changes in living conditions. And when we are talking about changes in living conditions, then we have indicators for endpoints. So we are talking about damage to the ecosystem, and in this case, to the ecosystem quality. So this is important to take in consideration that there are methods that go into the problem analysis, which are usually more precise, more rigorous, because it's something that we can measure with a device. And then there are the on top of that, there are the indicators that are damage oriented, and those usually are more difficult to measure directly with an equipment, but they can and should be, of course, addressed because it's what ourselves as humans are worried about: our health, our ecosystem quality, and the availability of resources. So there is this dichotomy of midpoint and endpoint methods. So normalization is just something that I would like to highlight. As I said, there are different impact categories. You can have damage to water, soil, etc. But usually what these methodologies do by normalizing is that they divide the result in each category by the average result, for instance, of a European citizen. So we have our footprint measured on average as European citizens in every of those categories. And the normalization step, what it does, it's basically tells us, for instance, what a given product system's impacts are related to the average impacts of a European citizen in the given categories for 1 year. So that is a way to normalize things. And this is an example of normalized results, for instance, for different types of bottles. So I will not, our time is skipping away, so I will not go through this. This is, well, a diagram of RECIPE method, which is widely used method for environmental impact assessment. As you can see from left to right, you have the LCI results, so you have the substances accounted for. Those substances can be transformed into the environmental mechanisms of the different categories that can then be transformed into midpoint indicators. So they are problem-oriented indicators. And then again, those problem-oriented indicators, they can be converted into endpoint indicators, which are damage-oriented indicators. And that is how, or that is the type of results that we'll be getting. So we'll be getting results from each of these environmental impact categories, and then we can convert also these results into damage results. So interpretation, just to finalize my presentation here. So interpretation has everything to do, of course, with the goals and of the LCA. So if we are trying to do a comparison of two products, or if we are trying to compare to a benchmark, or it depends on the goal. So, but most important, so we should always focus on the significant issues. So the LCA will provide us with a lot of results in many different impact categories, and we should be able to encounter our way within that mix of results. So most important is to keep the focus and identify the key issues in terms of the results. So we have to focus on what is the life cycle stage that is most important. What are the impact categories that are most significant, and then try to identify where the environmental impacts are coming from. So what is the process, or what are the processes that are responsible to generate the specific or most significant environmental impacts? And then we should be able to address those future to improve. Also, in terms of the robustness of the methodology, we should take in consideration the results regarding the completeness of the information and data available. Also do the sensitivity analysis and checks on consistency of the data and results, always to try and avoid any misunderstanding about results or some strange results that could very easily happen. And we should always try to be very self-critical about those results and be able to be fully confident about their robustness and representativeness. Also, we should provide conclusions on the results, but also identify the limitations on either the methodology or the results. And its LCA is never done to its full extent. So the methodology is highly intensive in data and all of that. So in effect, an LCA, even a full LCA methodology, is never done to its full extent. So it's not an exact picture of the product system. It's always a representation. So we should be able to say what are the limitations that the methodology and the results have comparing to the reality, and also provide some recommendations on how to improve for future LCAs, or even coming from the results of the LCA, how to improve on the product or the product system.